Let's go to page 506, and this is lesson 8.1, and this is to investigate angle sum in polygons. So question, what is the sum of the measure of the interior angles of a convex end gun? Okay, so to answer this question, what we need to do is, let's go ahead and do some investigation. So let's look at different polygons. Okay, so if you have three sides, it's a triangle, so you're going to get one triangle. Okay. Now, if you have four sides, okay, then you can cut and get two triangles. Okay, and so forth. So if you got five sides, okay, so you can cut into triangles. So this you get three triangles, okay, and so forth. Now if you have six sides, 1, 2, 3, 4, 5, 6. Okay, so you can cut into four triangles, okay, and so forth, right? So if you get seven sides, okay, so again you can just cut random triangles. Again, you can just cut any triangles. Okay, so you're going to go 1, 2, 3, 4, 5. Okay, so if you notice that the number of triangle is always 2 less than the side. Okay, so notice over here. So the number of triangles would be n minus 2. Okay, so if you notice n minus 2, this is number of triangles. Okay, so n minus 2 give you number of triangles. So if 5 sides, you minus 2, you get 3 triangles. Okay, so number of triangles you're going to get from a polygon is n minus 2. And as you recall, every triangle, the sum of the angle in a triangle is 180. Okay, okay, so you need to multiply by 180 degrees, and this will give you sum of interior angles. Okay, so that's how you figure it out. Okay, so again, to figure out the total angle inside a polygon, first you cut into number of triangles, and the number of triangles you're going to get is n minus 2. Right? So again, 3 sides you get 1, 4 you get 2, 5 you get 3, 6 you get 4, 7 you get 5. So it's always 2 less. So number of sides minus 2 will give you number of triangles. Okay? And each triangle is 180 degrees. So you multiply by number of triangles, and this will give you sum of the interior angles. Okay, so let's go to 8.1, find angle measure in polygons. It says in a polygon, 2 vertices, there are endpoints of the same side are called consecutive vertices. So consecutive means you one after the other like this. Okay. A diagonal of a polygon is a segment that joins 2 non-consecutive vertices. Okay, so like this would be example of diagonals. Okay, because it joins 2 points that are not consecutive. So if it's consecutive, it's a side. If it's not a consecutive vertices, it's a diagonal. Okay. It says polygon ABCDE has 2 diagonals from vertex B, so you got BD and BE. As you can see, the diagonals from one vertex form triangles. In the activities on page 506, the activity in the previous page, you use this triangle to find the sum of interior angle measure of a polygon. Your result supports the following theorem and corollary. Okay. So here's the theorem, polygon interior angle theorem. So you have a polygon. So the sum of the measure of the interior angles of a convex. Okay, convex means it's kind of going out. It's not caved in. It's kind of bulged out. Okay, from every side. Okay, so the interior angle of a convex end gun is n minus 2 times 180. Okay, so again, so all the angle that you measure, angle 1 plus 2 plus 3 plus, so you add all the 6 angles together, okay, it will give you equal to n minus 2 times 180. Again, n minus 2 is give you number of triangle, and each triangle is 180. Okay. Now, corollary to theorem 8.1, interior angle of a quadrilateral. Quadrilateral, quad means 4. Okay, so quadrilateral means 4-sided. So sum of the measure of interior angle of a quadrilateral is 360. Okay, because again, quadrilateral means 4-sided, so 4 minus 2 give you 2 triangles. 2 triangles times 180 give you 360. Okay. Okay, now let's go to example 1. Find the sum of angle measure in a polygon. Okay, find the sum of measure of interior angles of a convex octagon. So octagon means 8 sides. Okay, so over here is your formula. Okay, so 8 sides minus 2 give you number of triangle. So this give you 6 triangles. And 6 triangles times 180 give you 1080 degrees. Okay, so that's how you figure out the total angles inside an octagon. Okay. Okay, now let's go to example 2. It says find the number of sides of a polygon. So this is kind of going backward. Okay. So it says the sum of the measure of interior angle of a convex polygon is 900 degrees. Classify the polygon by the number of sides. Okay. So now this one you kind of have to work kind of backward. Okay. So you don't know how many sides it is, right? So that's your n. So that's the number of sides. And you have to minus 2. This gives you number of triangles. And you have to times by 180 degrees. This will give you total angle. Okay. And that total angle is equal to 900 degrees. Okay, so now you have to solve. Okay, so before they give you number of sides, you have to figure out the total angle. Right now they give you total angle, you have to work backward to find number of sides. Okay, so this one don't multiply out. Okay, so what you want to do is you divide by 180 degrees, so that this will cancel out, and so n minus 2 will equal to, use your calculator, and equal to 5. Okay, then after you plus 2. So you don't want to multiply out right away. You want to divide. Okay, that way if you can multiply, but it takes longer and it's more messy. Okay, so it's easier if you divide first. Okay, and then from here it's a little bit easier. So n equal to 7. Okay, so this is 7-sided, and the name of the 7-sided shape is called heptagon. Okay, so 3, so triangle. So 3 means triangle. 4 side means quadrilateral, 5 side is pentagon, 6 side is hexagon, and 7 sided is heptagon. Okay, so that's a heptagon, and 8 sided is octagon. Okay, so kind of be familiar with those names. Okay, now if you don't remember all the names, just go ahead and Google it. So there's something for you to, to check it out. If you don't know all the names, just go Google names all the way up to 12 sides. Okay. Okay. Now let's go to example 3. Find the value of x in a diagram show. Okay. Okay, so you have this diagram. So it's quadrilateral, 4-sided, right? So 4-sided. So 4 sides minus 2 give you number of triangles times 180. Okay, and also from the corollary, we know that 360. But in case if you don't remember 360, okay, you just go ahead and just work it through. So this will equal to the total. So this will give you the total angle, and it's equal to 108 plus 121 plus 59 plus x. Right? So again, 4 angles. You add up all 4 angles, should equal to the total. Okay, so you got 360 equal to, get your calculator. So 108 plus 121 plus 59 equal to 288 plus x. Okay. Then minus 288 on both sides. So x will equal to 72 degrees. Okay, and that's your answer. Okay. Okay, now let's go to page 509. Now we're going to do the exterior angles. Right. It says, unlike the sum of interior angle measures of a convex polygon, the sum of exterior angle measured does not depend on the number of sides of a polygon. The diagram below suggests the sum of the measure of the exterior angles, one at each vertex of a pentagon is 360. In general, this sum is 360 for any convex polygon. Okay? So let's say if you have a polygon, in this case pentagon, okay? So if you notice the shading, so step one, shade one exterior angle at each vertex. Step two, cut out the exterior angles. Then arrange the exterior angle to form a 360. Okay? So from this you can see the exterior angle of no matter how many sides is always 360. Okay, so here's your theorem. Theorem 8.2. Polygon exterior angle theorem. The sum of the measure of the exterior angle of a convex polygon, one angle at each vertex is 360. So again, it doesn't matter how many sides, okay? The total number of exterior angle, the total degree of the exterior angle will always equal to 360. It does not matter how many sides, okay? Whereas interior angle changes depends on number of sides, right? Because you can cut into different number of triangles. Okay. So let's go to example 4. What is the value of x in the diagram shown? Okay. So you can this will equal to 360, right? So you just write down your formula. So you have the x plus the 2x plus the 89 plus the 67. They will equal total 360. Okay, and use your algebra, combine the like terms. So this will give you 3x. This 2 will give you 156. Minus 156 on both sides, so you get x equal to 68. And that's your answer. Okay. Okay, now let's go to example 5. Okay, for example 5, you have a trampoline. Okay, so the trampoline shown is a shape like a regular dodecagon. Okay, now the regular means all sides are equal and all angles are equal. Okay, and dodecagon means 12-sided. Find A, the measure of each interior angle, B, the measure of each exterior angles. Okay, now over here I'm going to do the regular way and I'm going to show you the quicker way to do this. Okay, so first let's do the A. Measure each interior angle. So this is 12 sides, right? So first we have to figure out the number of total angles. So there are 12 sides. You minus 2 to get number of triangles. You times by 180. So this gives you the total angles. Okay. So this will give you, okay, so this is 12 minus 2 is 10. 10 times 180 will give you 1800. Okay. So this is the total angles. Now, since the regular polygon, the regular dodecagon means every angle is equal, so you can just divide this by 12 to find each angle. Okay. So equal to 150 degrees. Okay, so this will be interior angle. Okay, now B, to find exterior angles. Now remember, exterior angle is always 360, right? So the exterior angle is always 360, and there are 12 sides. Therefore, there will be 12 exterior angles. So you divide by 12. Okay. So 360 divided by 12 equal to 30 degrees. Now, what did you notice about exterior angle and interior angles? They are supplementary, right? They have to equal to 180, okay? So instead of doing this long way, what you do is whenever you have a regular, now this only good for to do this, you only can do this when you have a regular polygon, okay? So when all angles are equal, then you can divide. If it's not a regular polygon, then you cannot do this method, okay? So another quick way of finding the interior angle for a regular polygon is you figure out the exterior polygon first because it's easy to do. Then after you take the supplementary. So once you find exterior angles, you just use 180 minus 30, you get 150. That way you don't have to go through this whole thing. Okay, so you can use a supplementary angles. Okay, so remember, okay, so whenever now this is only good for a regular polygon. Okay, so for regular polygon, you divide to find the exterior angle, and then use 180 minus that to get interior angles. Okay, that way you don't have to try to figure out the total angle, then you have to divide. Okay, so this is a longer way to do it. The quick way, just do the exterior angle and take the supplementary, and you get the interior angle.